Hello and welcome to Equine Science Talk. Today we're talking about one-sidedness and crookedness in the horse.
Most of us have experienced this at least once. You go past something with your horse and it's relaxed and nothing happens. But when you turn round and come back, it suddenly spooks at the spot that was no problem going the other direction.
When talking about sidedness and crookedness in horses, we need to distinguish between three different types, or parameters. The first is the physical crookedness. 80 to 90% of mammals, and in fact all animals, are born crooked. This is probably because they lie crooked in the womb and because the internal organs are not positioned symmetrically.
The second is so-called motor laterality, meaning a preference for the left or right limbs, in the case of horses usually the forelegs. Motor laterality can be expressed in a preferred foreleg when standing and grazing, and also as the foreleg that moves first when the horse sets off, either with the left or the right being preferred. This can be assessed with or without a pole. Motor laterality in horses is comparable to handedness in humans. However, unlike humans, in wild horses, the preference is more or less evenly distributed between left and right-sided horses. Motor laterality can be influenced by breeding, training, stress and age.
The third parameter is sensory laterality. This means the preference for the sensory organs on one side of the body. People have this type of laterality too. If I look at you through the triangle of my fingers, I have the impression that I'm looking at you with both eyes, but you can see quite correctly that I'm really looking with my right eye. If I close my right eye, I can't see you anymore. It's a thought I'm looking at the horse through the triangle and then somebody takes it away. Horses prefer to approach objects with the sensory organs on their left sides. Some then switch between left and right while they're investigating the object. First, they look to see whether the object is dangerous. Then they decide what they can do with it. Perhaps even eat it.
Sensory laterality is the result of specializations of the two halves of the brain. The right hemisphere is the reactive side. It's active when the horse is stressed or frightened and regulates the corresponding bodily functions. The left hemisphere is the proactive side. It's active when the horse is involved in routine activities or when it's learning.
If we want to work out which hemisphere the horse is using to process information, we also need to know that the right hemisphere processes information coming in from the left ear and eye, and the left hemisphere processes around 80% of the information coming in from the right ear and eye. It's also important to know that information moves between the two hemispheres, from left to right and from right to left. We know this from research in the 1970s on so-called split brain patients. People suffering from epilepsy were treated by cutting the connection between the left and right hemisphere. When these people were suddenly shown, for example, a pen, they were clearly startled and looked at the pen with their left eyes. As they went on to consider what type of pen it was, what color it was, and so on, they switched to looking at it with their right eyes in order to make a rational, considered decision.
So, what does all this tell us about the horse we were discussing at the beginning? It means that incoming information is processed differently depending on the side. The left eye decides what type of information it is, while the right eye examines the object more closely. This means that to keep the horse as calm as possible, we must give it the opportunity to look at an object with each eye. Scientists discovered this in a test in which they covered the left eye. The horses became so unsettled they had to cancel the experiment, and it was clear that the horses needed to use the left eye to be able to assess a new object. There are other factors that affect laterality too. There's the breed of horse, its age and its character, as well as stress, which is a very important factor that can impact on laterality. Researchers found that horses that were exposed to stress caused by changes in their living conditions and training showed a shift in laterality to the left. They used their left eyes more often and also showed a stronger preference for putting their left foreleg in front while eating. They also found that sensory laterality changes more quickly than motor laterality and responds to short-term stress, while motor laterality only changed after longer periods of stress.
In addition to this, when approaching people, horses show a preference for keeping the person on the left eye. We also see this phenomenon in social interactions between horses themselves. Horses approach each other left to left for friendly interactions as well as for aggressive confrontations.
Laterality can even indicate the horse's state of mind. It can show whether it's feeling optimistic if it approaches a neutral object with positive expectations, or pessimistic if it has negative expectations. This so-called cognitive bias can be measured in an experimental setup. For the test, the horses learned first of all how to open a box to reach a carrot inside. In the learning phase, the horse was repeatedly presented with the box in a positive location with a carrot in it for the horse to eat, and in a negative location in which the box was locked so that it couldn't reach the carrot. In the final test phase, the box was placed in the middle, representing a neutral location. The horses that approached the box in the new location were considered optimistic, and those that didn't, such as the one here, were considered pessimists. The results of this study showed that the pessimistic horses set off from the starting point with their left forelegs more often than the optimistic horses.
And a final note.
Laterality seems to be the result of a long evolutionary process, as we see similar asymmetries in both vertebrates and invertebrates, and in general the right hemisphere is in charge of short-term memory and the left controls long-term memory.
It has recently been discovered that laterality appears to be already developing at the embryo stage, and while genetics seem to play an important part, it is also influenced by environmental factors.
That's all for now. Don't forget to subscribe to the Equine Science Talk channel, and you can leave your questions and comments below. Thanks for watching, and we'll be back soon with more Equine Science Talk.